Good morning. Today's March 9th, so a few students requested that I start making videos again, and I thought it'd be a good idea as well. So went ahead and downloaded today's notes, 7.4, intercept form of quadratic function. We're going to talk about these notes, and then at the bottom you'll have a practice assignment. Sorry, I didn't mean to click my teeth so loud there. You'll have the exit ticket, and you'll complete that for homework. But prior to that, we'll talk about what intercept form looks like. So as you noticed, and as I talked about previously, Unit 7 is all about graphing quadratic functions. And quadratics are anything with the highest exponent of 2, right? All right. So if we take a look, you can see in this graph below, it says where on the graph are the solutions? Well, the solutions to this graph are at 1, 0 and -5, 0. Okay, so that's the solutions to that graph. Well, that graph happens to also be represented by this quadratic function. Now, from here, this is the standard form. What we learned yesterday is that you would have to set x equal to -b over 2a, label your a, b, and c's, and then plug it in and do all that stuff, right? Well, sometimes there might be an easier way to do that, and that's using factoring like we just did on our most recent test. So in a function like this, it says solve the following. We can solve it simply by factoring it. Okay, so x squared gets split into x times x. The factors of -5 are -5 and 1, -1 and 5. And of course, the second option here is what gets you +4 when you add them together. So it'd be x minus 1 and x plus 5. And then we use the zero product property to set them equal to 0. And that'd give you a +1. Right? I guess I should write it all the way out just in case here. So you add 1 to each side, that would give you a +1. And then when you subtract 5 from both sides, that would give you a -5. Okay? So that is factoring the quadratic. You factor it into two sets of parentheses, and then you set each one equal to 0 using the zero product property. So our solution should be x equals 1 and x equals -5. Well, if you look at the graph, okay, that's exactly what we have here. We have x is -5 and x is +1. So you can see that we can actually graph it using intercepts, okay? And that's what we call this. We call this intercept form, and it looks like this. Y equals a times x minus p times x minus q. So basically, you take the two intercepts. This a value out front, okay, is usually like a stretch or a compression, and it can also be positive or negative. So if a is positive, right, then it's up. If a is negative, then it's down. Okay, so if there's a positive out front, it's facing upwards. If it's a negative out front, it's facing downwards. And notice p and q are negative inside the parentheses, but in your intercepts, like on the graph, they would be the opposite of that. Okay, so it's always the opposite of what's inside the parentheses there. Okay, so let's take a look at some examples of intercept form here. Like for instance, this first one says, where are the x-intercepts in the following parabola? Well, this one is at 2, 0, and this one's at -2, 0. Okay, so -2, 0, and 2, 0. But then it says write the equation in standard form. Well, the equation for this, okay, would be y equals, since it's positive, a would be positive, so we don't need to put anything there. Okay, so this would be x into x, and then you put minus, minus. Well, then our values are -2 and +2. Well, if I put minus -2 and minus a +2, you can see that I'm going to need to change the sign in this first parenthesis. And so our formula actually becomes x plus 2, x minus 2, which makes sense because then when I set them equal to 0 and solve, I would have a -2 and a +2, -2, +2. Okay, so this is intercept form, and you can use it just by knowing the intercepts. Now, can you find the vertex of the parabola? Remember, vertex, as we talked about, is the point, right? So can you find the vertex of a parabola if you already know the intercepts? Okay, so let's say this was what, -5, 0, and 1, 0. Okay, so the vertex, if you're looking at a graph, is always going to be on the axis of symmetry. So if we look here, we have 1, 2, 3, 4, 5, 6 spaces. So if we go half of that way, that would be 3. Okay, draw a straight line right down through, and you can see that actually our vertex here on the graph is right there as well, and that would be at -2. Oop, I didn't realize I still have the dotted font. That vertex would be at -2, comma, let's see, -6, -7, -8, -9. Okay, so there's a vertex. So the answer is yes. And not only can you do it from a graph, okay, but you can also do it algebraically. So for instance, if I have, if I look at the graph and I look and I see that my x value is -2 because I know that my x-intercepts are -5 and +1, well, how many spaces are in between those, right? There are, as we said, there are 6 spaces. Okay, so 1 minus a -5 gives you a +6. And so 3 spaces in between there. Okay, it puts you at -2. So x equals -2 is the axis of symmetry. Okay, these are our solutions. So if x equals -2, you could solve this one just by plugging it back in. So if the formula was x plus 5 and x minus 1, remember it's the opposite, well then I can plug in that -2 and get my y value of my vertex, which this would be a +3, this would be a -3, which would give me a -9 when you multiply them together, which, as we wrote, what was it before? -2, -9. So you can also get it, the vertex, not only by looking at the graph, but if they give you the formula, okay, going halfway between these two values and then plugging that value in. All right, so let's go on to the next example here. We're going to identify the x-intercepts, then find the vertex of the parabola. Check with Desmos. Okay, so you have x plus 2, x minus, or x plus 4, x plus 2. So you set those equal to 0. So when you subtract 4 from both sides, you would get x equals -4. Subtract 2 from both sides, you get x equals -2. Okay, so those are our intercepts. Okay, so the intercepts would be at -4, 0 and -2, 0. All right, and then it wants to know what is the vertex. Well, the vertex is halfway between there, right? So what's halfway between -4 and -2? What's between that? Well, -3 is, right? So let's plug that in. So y equals -3 plus 4 and -3 plus 2. And that gives you a +1. This one gives you a -1. And so y equals -1 when you multiply them together. So my vertex for this example is at -3, -1. Okay, so that's kind of how you look at that. And you can see that's nice because these repeat. So this is going to be, let's see, -3, -1. This is going to be an upward facing graph because it's positive out front. Okay, now we could check that with Desmos as well. And I'll do that for this first one, but not for the second one. Okay, just by plugging it in. So, x plus 4 times x plus 2. Okay, there's an intercept. Yep, got that. There's an intercept. Yep, got that. And there's our vertex. Got that one as well. Okay, so that's how you check it in Desmos. All right, let's go ahead and try number 2. So number 2, again, set both of these equal to 0. So x minus 2 equals 0. X plus 3 equals 0. What's the opposite of those? Well, that would be a +2 and a -3. So our intercepts would be at 2, 0 and -3, 0. Okay, so how many spaces are between those? So you have a -3, and then you have a +2. So you have, let's see, let's just go in order here. So -2, -1, 0, 1, 2. So how many spaces? 1, 2, 3, 4, 5. Ooh, okay, so this is good. This is an odd number of spaces. So what's halfway between 5? Well, half of 5 is 2.5. So we're going to go over 1, 2 and a half, which puts us at about negative 1/2, right? 1, 2 and a half puts us right there at that negative 1/2 mark. Okay, so let's go ahead and plug that in. So negative 1/2 minus 2, negative 1/2 plus 3. Okay, that gives me negative 2.5. This one gives me positive 2.5. Okay, and then use your calculator, and that'll give you your y value. Sometimes, it's not going to be a whole number, and it'll be a decimal. That's okay, though, right? You just have to work out the problem and then check it with decimals. So your answer here would be negative 6.25. So our vertex would be at negative 6.25, and of course the x value would be at negative 1/2. Okay, and again, if you're not sure, check it with decimals. Okay, all right. Graph the following quadratics by graphing the vertex and the x-intercepts. Simple. Okay, so as you can see, it's the opposite of what's in the parentheses. So this would be positive 4 and positive 2. Okay, which means the vertex has to be halfway between those. Since there are only 2 spaces, halfway between would be a 3. So let's go ahead and plug in a 3 here. That'll give you a 1, that'll give you a negative 1. When you multiply those together, that would give you a negative 1. So our vertex would be at 3, negative 1, which is right there. And that's it. Okay, you could do a table for the rest of the points, but I'm not going to make you do that right this moment. Okay, same thing here, only now this one is in, this is supposed to be a negative 27, by the way. So let's replace that. Okay, so how can we graph this one with intercepts and vertex? Well, it's in standard form right now, but we can go back to what we know about factoring. Okay, these both have a GCF of 3, so you put a 3 out front, and now you've got x squared minus 9. Ooh, remember that 9 is a perfect square, and so is x squared. And since there's no middle number in here, that means they got to cancel out. So this is the same thing as saying y equals 3, sorry, x minus 3 and x plus 3, because the square root of 9 is 3, right? And then you need a positive and a negative to make sure that there's no middle number. And then, of course, the 3 out front is the GCF that we factored out initially. Okay, so what would be our intercepts here? They'd be positive 3 and negative 3. Okay, so let's plug that in. 3, negative 3. And then halfway between those, of course, is 1, 2, 3, 4, 5, 6 would be 0. So we're going to plug in a 0 to find our vertex. This would be negative 3, positive 3. Ooh, lots of 3s. So the y value here is going to be 3 times 3 is 9, times 3 is 27. This would be negative 27, which ironically is up here, which is our y-intercept. Okay, so that one's kind of tough to mark. It's going to be like way up there somewhere. So we're just going to draw a line. Oh, I'm sorry, way on the bottom. It'll be way down here somewhere, right, at negative 27. So we're going to do something like this. Okay, so that's where our y-intercept would be on that one. Okay, take a minute, pause this, get it copied down if you need to. All right, as we continue to move on. All right, so last page here before you get to your exit ticket. Next page says, write an equation for the following information. Okay, so we want to write an equation where the x-intercepts are 2 and negative 4, and the vertex is a maximum. So maximum means it's got to be at the very top, right? like it's the top of the mountain. So that means it needs to face downwards, which means that A is negative. Okay, so that means our equation is going to be y equals a negative number. And then we have our intercepts, which are x and x, and it looks like our intercepts are 2 and negative 4. So remember that it's the opposite, so this would be minus 2 plus 4. It's as simple as that. So it's got a maximum. That makes it negative. If it were a minimum, it'd be a positive out front. And then your intercepts are the opposite. Okay, convert the following into standard form. Okay, so now notice that this one is an intercept form. Let's go ahead and convert it to standard form. And to do so, you just expand it out. You multiply it out. FOIL. First, outside, inside, last. So first is x squared. Outside, negative 4x. Inside, negative 2x. And lasts, positive 8. And then simplify that. Minus 6x plus 8. Okay? And that's it. And again, you can check all of these answers with Desmos. And how do you do that? You plug in this first equation, plug in the second equation, and see if they're the exact same graph. If they're the exact same graph, then you know that it's good. That it's a good conversion. Okay, this one, write the intercept form. Oh, so okay, so intercept form, remember we got to factor it, so we're working the opposite way. So standard form, if it's in intercept form, you're going to basically FOIL it. If it's in standard form, we want to put in intercept form, we want to factor it. So you're going back and forth between the two different varieties, right? X and x, factors of negative 3 or negative 3 and 1, negative 1 and 3. The bottom one's going to get you a positive 2, so that's what it would be. Okay, and then it's positive out front because this one's positive out front. So that's the solution there. Okay, intercept form, again, we're going to factor it. Okay, first thing we look for when we factor is a GCF. This one has a GCF of 2. So now that leaves us with, let's see, x squared plus 4x plus 3. So now we have, when you factor that, x and the factors of 3 that are positive and positive are just 3 and 1. So 3 and 1, and when you add those together, 3 plus 1 would also give you 4. So you know that that one's good as well. So here's our factored form on this one. Okay, and again, the 2 out front is going to make it a stretch, which we'll talk about at a later time. Which of the following equations would graph the parabola below? Use your intercepts. Okay, so our intercepts here are 0, 0, and 4, 0. So which one of these would have those intercepts? Well, we know that it's positive 4 here, but in the equation it's got to be negative. So right off the bat, we know that these can't be it because they both have a positive 4, right? So it's got to be one of these two. So now, which one of these, okay, would be equal to 0, 0? Or, yeah, because this would be positive 4. Well, look, if I set negative x equal to 0, divide by negative 1, what's 0 divided by anything? Still 0. Okay, well, let's try the top one here. X equals 0. Again, we're using zero product property. Well, there's nothing else I can do for that one. So in this case, there are actually 2 equations that would graph this one. Right? Except for one problem. This faces which way? Down, right? So if it faces down, it has to be this one because it's got the negative out front. Okay? So that's how you figure that out. Look at your intercepts, okay, and then look, is it positive or negative? All right, using the following graph, write a quadratic function in intercept and standard form. This is kind of a challenge example, but we're going to go through it anyways. Okay, you have an intercept here of negative 1, 0. Intercept here of 3, 0. Okay, it's positive. So let's write an equation. Remember, it's always going to be the opposite. So since it was negative 1, it's going to be plus 1. And since it's positive 3, it's going to be negative 3. Okay, now how can we write that in standard form? Well, pretty simple. Let's just multiply it out. Now that we got one form. Okay, FOIL first, outside, inside, last. Okay, and that simplifies to x squared minus 2x minus 3. All right, so there's our standard form. Y equals x squared minus 2x minus 3. So that's it. So you got your standard form, you got intercept form. We worked on standard form so far this week. Intercept form is what's new today, where you're just looking at the intercepts. Okay, hopefully this video made sense for you. If it didn't, maybe pause and go back, pause it in certain spots, retry it a little bit, and then let me know if you have any questions, okay? And then your exit ticket are very similar questions. You're going to graph it, okay, with the vertex and all that. Okay, when you go to find the vertex, think about what's halfway between your intercepts, plug it back in, that'll give you your values, and then your standard and intercept form. Okay, again, if you got any questions, let me know. I'll see the rest of you in